color used to identify the high leg, sometimes referred to as the stinger leg or wild leg, in a 4-wire delta-connected secondary electrical system was changed in the 1999 revision of the National Electrical Code, or NEC. Prior to the 1999 NEC, the identifying color for the high leg was purple. The 1999 NEC and subsequent editions mandated the use of orange as the identifying color for the high leg. This change aimed to standardize the identification of the high leg across different installations and jurisdictions, thereby improving safety and reducing the risk of accidental connections that could damage equipment or endanger personnel. It's important to understand what a 4-wire delta system is and why a high leg presents a unique consideration. A 4-wire delta system is a type of 3-phase electrical distribution system that utilizes a delta-connected transformer secondary. In a delta connection, the 3 windings of the transformer are connected in a closed loop resembling the Greek letter delta. The 4-wire aspect refers to the presence of 3-phase conductors, typically labeled A, B, and C, and a neutral conductor. The neutral is derived from a center tap on one of the transformer windings, specifically the winding that provides single-phase power at a low voltage, such as 120 volts in a 240/120 volt delta system. The voltage between any 2 phase conductors in a delta system is the same, but the voltage between one of the phase conductors, the high leg, and the neutral is significantly higher than the voltage between the other 2 phase conductors and the neutral. This higher voltage is approximately 1.732, which is the square root of 3 times the voltage between the other 2 phase conductors and the neutral. For example, in a 240/120 volt delta system, the voltage between phase A and phase B and phase C, and phase A and phase C is 240 volts. The voltage between phase A and neutral and phase C and neutral is 120 volts. However, the voltage between phase B, the high leg, and neutral is approximately 208 volts. This higher voltage on the high leg can be problematic if not properly identified because connecting a 120 volt load to the high leg will result in overvoltage and likely damage the equipment. The NEC mandates specific requirements for marking and identifying the high leg to prevent such misconnections. Section 110.15 of the NEC requires that the phase having the higher voltage to ground be durably and permanently marked. The means of identification must be applied at each point where a connection is made if the grounded circuit conductor is also present. Typically, this is achieved by using orange color tape paint or other approved means of identification. The orange color must be consistently applied throughout the electrical system to ensure clear and unambiguous identification of the high leg. The NEC also addresses the location and accessibility of the high leg. Section 408.3 E addresses the phase arrangement in panel boards. In panel boards, the phase arrangement on 3-phase buses must be A, B, C from front to back or left to right, as viewed from the front of the panel board. The B phase is the high leg, which is always in the center position. This standardized arrangement helps electricians and other qualified personnel to quickly identify the high leg and avoid accidental connections. Article 408.3 F of the NEC states that the high leg must be marked. On switchboards or panel boards having any devices connected line to neutral, the conductor or busbar having the higher voltage to ground must be durably and permanently marked. This marking must be visible and readily accessible to anyone working on the electrical system. The marking can be accomplished by using orange-colored tape, paint, or other approved means. The marking must also indicate the voltage to ground of the high leg, such as 208 volts to ground. The use of orange as the standard color for identifying the high leg has significantly improved electrical safety and reduced the risk of accidental connections. By consistently applying this color code, electricians and other qualified personnel can quickly and easily identify the high leg and avoid making connections that could damage equipment or endanger personnel. It is important to note that the specific requirements for marking and identifying the high leg may vary depending on local codes and regulations. Always consult the latest edition of the NEC and any applicable local codes before working on a 4-wire delta system. Some jurisdictions may have additional requirements or restrictions that must be followed. The 1999 NEC update to change the highlight color from purple to orange was a significant step in harmonizing electrical safety practices across North America. Older systems marked with purple tape should be retrofitted with orange markings to comply with current standards and minimize the risk of confusion. When working with electrical systems, it is always best practice to verify the voltage of each conductor before making any connections. This can be accomplished by using a voltmeter to measure the voltage between each phase conductor and the neutral conductor. The high leg will have a significantly higher voltage to ground than the other two-phase conductors. It is also important to ensure that all electrical equipment is properly rated for the voltage of the circuit to which it is connected. Connecting equipment to a circuit with a higher voltage than it is rated for can damage the equipment and create a safety hazard. In summary, the color identifying the high leg on a 4-wire delta-connected secondary was changed from purple to orange in the 1999 revision of the NEC. This change was made to standardize the identification of the high leg and improve electrical safety. When working with a 4-wire delta system, always verify the voltage of each conductor before making any connections and ensure that all electrical equipment is properly rated for the voltage of the circuit. Remember to consult the latest edition of the NEC and any applicable local codes before working on any electrical system. Furthermore, continuous education and training on electrical codes and safety practices are crucial for electricians and other qualified personnel. Changes and updates to the NEC occur regularly, and it is essential to stay informed about the latest requirements and best practices. Many organizations, such as the National Fire Protection Association, or NFPA, and the International Association of Electrical Inspectors, or IE, offer training courses and resources to help electrical professionals stay up to date on the latest codes and standards. In addition to the NEC, other standards and regulations may also apply to electrical installations. These may include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the American National Standards Institute, or ANSI. It is important to be familiar with all applicable standards and regulations before working on any electrical system. Working with electricity can be dangerous, and it is essential to take all necessary precautions to protect yourself and others from harm. Always wear appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and insulated tools. De-energize and lock out electrical circuits before working on them whenever possible. If it is not possible to de-energize the circuit, use extreme caution and follow all safety procedures. Finally, it is always a good idea to have a second person present when working on electrical systems, especially if you are not familiar with the system or the task. The second person can provide assistance and call for help in case of an emergency. The NEC is a comprehensive set of rules and guidelines for electrical installations, but it is not a substitute for sound judgment and common sense. Always use your best judgment when working on electrical systems, and do not hesitate to ask for help if you are unsure about something. By following these guidelines, you can help to ensure that electrical installations are safe and reliable. This includes paying close attention to seemingly small details, such as the color coding of conductors, as these details can have a significant impact on safety and performance.